In the last video, we looked at what an Ethernet frame looks like and the various frames, or I should say the various fields within that frame, what their names were and what they were used for. And I talked a little bit about the minimum and maximum sizes of an Ethernet frame. I'd like to talk a little bit more about that now. So there are terms for Ethernet frames that fall outside of the scope of a minimum sized and a maximum size frame. And when you see something like that, this is generally indicative of some kind of an error. So let's talk about a runt. A runt is any Ethernet frame that is less than the minimum MTU. So MTU stands for maximum transmission unit. Maximum transmission unit is the largest a frame could be. Now we said that Ethernet said that the data of a frame could be no less than 46 bytes. And then when you add on, for example, the source address, the destination address, and the FCS field, the entire Ethernet frame, the smallest a frame could ever be, would be 64 bytes total. So if an Ethernet NIC card ever receives an incoming frame and it says, it just stopped, no more bits coming in, but I only got enough bits that were 35 bytes or 50 bytes, it'll say, that's too short. That frame at minimum should have been 64 bytes long, and that is considered a runt. So that frame will be discarded. It did not meet the legal minimum size of an Ethernet frame. As it says here, that's typically caused by collisions, malfunctioning NICs, or software issues. And then just the opposite. Any frame that's larger than 1518 bytes. So once again, 1500 of data, and then 18 bytes when you add in the destination MAC, source MAC, and FCS field. That adds up to 18 bytes. So a regular Ethernet frame should not be any larger than 1518 bytes. If it is, that will be excessively large, and that will be called what's called a giant. And the giant frame will be discarded because that's also an error. Also typically generated by malfunctioning NIC cards. Or possibly you've got something called jumbo frames configured on one side but not on the other side. So we'll get into jumbo frames here in just 1 second. Now if you're familiar with LAN switching, you're familiar with 802.1q tags, you know that an 802.1q tag adds an extra 4 bytes to something. So if I have two switches connected end to end and they're both configured for 802.1q, they will actually accept frames up to 1522 bytes. They'll say, okay, a maximum Ethernet frame would be 1518, but there's going to be an additional 4-byte tag in there, which will bump it up to 1522. Technically, we call that a baby giant. A baby giant is something that's just slightly larger than a maximum size Ethernet frame, and that will be okay. That'll be acceptable. Now, what if we had this scenario? So my upper layer data, whatever it is, has sent down to TCP, let's say, 8,760 bytes of data. So what would TCP do with that? Well, there is some interaction between layer 2, layer 3, and layer 4 to where TCP up at layer 4 will recognize, okay, I can't put this into a single TCP segment because if I do, it'll be too large for the Ethernet frame. The Ethernet frame can only have 1,500 bytes of data. So what TCP would do is it would break that into 6 different segments of 1460 bytes each. It would add the TCP header, and you'd have the IP header. And that would end up resulting in 6 maximum-sized Ethernet frames. So that one chunk, that one block of data resulted in 6 Ethernet frames, and each frame you can see here is spaced with the interframe gap in the middle of them. Well, what if I have a scenario where I've got 2 servers that need to communicate, and these servers are doing massive data backup? Maybe they're connected via like a gig link that's super fast, and they just have to slam each other with data, massive data transfers. Well, this will work, but wouldn't it be more efficient if I could actually create one Ethernet frame that contained all of that? And that's what's called a jumbo frame. So jumbo frames are not supported by default, but if you have the hardware, for example, if the adapter on your NIC card supports it, if your adapters on your switch interfaces and your router interfaces support it, you can actually configure all these things to support Ethernet frames that are larger than the maximum size. Now, the actual size of a jumbo frame is variable. It really depends on what hardware you're talking about. For example, Cisco Nexus switches support jumbo frames that are up to 9,216 bytes long. That's really large. Whereas some of the older workgroup switches from Cisco only support jumbo frames up to 2,000 bytes. So pretty big difference. So you'll want to find out, if there's any device along the path that does not support jumbo frames, that's it. You can't do it. So all the devices end to end between these two servers, in my example, including the servers themselves, would have to support jumbo frames in order to take advantage of this. And you want to make sure that they all support the same size, or at least set it to a size that is supported. Here you can see the command on a switch. This is on a 3560 switch to enable it for jumbo frames. And here I've also included a screenshot taken from a Windows 10 laptop of how you can enable jumbo frames on that. Typically you would not do this on a laptop. You're not really going to get any benefit on a laptop because most likely the switch you're connected to or your default gateway does not support jumbo frames. So that's why I said usually jumbo frames are something that are enabled end to end between like server connections. So that concludes this particular section. In the next and the last video for this series, we'll go into the different types of Ethernet cabling.